Hello and welcome to my channel. I am BeardedDev. In this video, which is part of the SQL Basics series, we're going to be looking at ordering, and the good news is you can follow along with this video. There will be code examples in the description below. So there's some prerequisites as with part 1. So you need to have either SQL Server or Azure SQL database, some database of some kind you can work with, a client tool like SQL Server Management Studio or Azure Data Studio, and the AdventureWorks database. I'm going to be using AdventureWorks 2019 for this demonstration, which is readily available online. So what we're going to go through in this video, it's all about ordering. So we're going to be returning results ordered by a column, multiple columns, columns in descending order, multiple columns with a different order, and then we're going to be looking at how we can write queries that limit the amount of rows returned. So let's head over to SQL Server Management Studio and we'll go through some examples. Okay, so we're in SQL Server Management Studio. As you can see, I'm connected to the AdventureWorks 2019 database. We're just going to start off with a very simple select. We're going to be selecting the customer ID from the sales.salesorder header table. I'm just going to execute that query now, and we can see we've got our results here of customer ID. Now a question for you here is that result ordered? And the answer to that is it appears to be ordered, but there is no guarantee that that result set is returned in the order of customer ID. So for an ordered set to be returned, we must explicitly state an order by clause. So when you look at queries and you think, well, that's clearly ordered by customer ID, you may be correct. SQL Server may have chosen to return results in that way. And typically that's the case if you've got indexing on the columns, but we won't go into that in this video as this is just basics. Now, to explicitly state that we want this ordered and to guarantee an order, we need to use the order by clause. So what I mentioned earlier is that it's not guaranteed, is that SQL Server can return the results any way it wants. So it could return customer ID 11,002 first if it wanted, and then 11,000. That would still be correct for what we're asking SQL Server to do. So we're going to go ahead and add the order by clause to this query. So what we simply write is the two words order by, and then we're going to give it a column to order by. And in this case, we're going to be ordering by our customer ID. We execute that query, and now it is guaranteed that that result set will be returned by customer ID every time, because we're explicitly stating that the results need to be ordered. Okay, so we've learned how to add order by now to our query. So let's build on this a little bit. Let's add additional columns. Let's add our total due. Execute the query. Okay, so we're going to look at this query in detail now. So we've got our customer ID, and we can see customer ID 11,000 has got 3 rows. Now we know the result set is guaranteed to be returned by customer ID, but if we look at the top 3 rows, they all relate to the same customer. So again, how is SQL Server returning those results? Well, again, now we're in a position where this is not deterministic, and what that means is that it's not guaranteed. It may decide next time we run the query to return the total due of 2,770 at the top, And again, that would be correct, because as long as it meets the criteria of ordering by customer ID, then it's still returning the results as we've asked it to do. But we have got an additional column, total due, and it can return that in any order it likes. So now we're going to build on this and add that to our order by. So I'm just going to add that to a separate line just for readability, and then we're going to add total due now to our ordering. And again, we're back in the position of we've now got the results guaranteed by customer ID and total due. However, here's the thing: what if a customer has the same amount, the same total due for different orders? Well, then we're in a position where it's non-deterministic again. So if we need it to be deterministic, we need an attribute of this table that's unique, and typically that's the primary key. So in this example, we have our sales order ID. So I'm just going to add that in. Notice that it's only part of the select. So let's say we want to order by customer ID, total due, and what we're calling this here is it's a tiebreaker. So if we have the same customer with the same amount total due, we're going to order by sales order ID. And I'm just going to drop that down actually from my select so it's easier to read. Execute the query, and we can see now that if we order by customer ID, we've got 3 here. If we had a tie, then the tiebreaker would be sales order ID. So now we've guaranteed that that's a deterministic order, because the sales ID is a unique value for every column. Now the next thing I want to mention is ordering by nominal positions. And what do I mean by that? Well, instead of explicitly stating our columns in the order by, we can actually just put numbers. And what these numbers represent is the actual columns within the table. So if we go ahead and execute this, we're actually, by mentioning position 1, we're actually asking it to return it by sales order ID. Now this is, I find, difficult to read, because if someone comes along and looks at this query, they can't just simply look at the order by clause and see straight away what that's ordered by. They need to have a look in more detail of what that one actually represents. Now the other danger of this is that if we reorder the columns, so if somebody comes along and adds a different column that they need to return within a query, we've then changed the ordering of the result. So we had customer ID initially as column 1 in the result set. We've now, someone's come along, they need to add an additional column, sales order ID. They've added that in that column position, and we've now changed the order of that result set. So that's why I don't like ordering by nominal positions, and I think it's actually quite bad practice. Okay, we'll just return to our initial query. And like I say, if you are following along, there will be the code examples in the description of the video, and you can just copy and paste those into SQL Server and change those as you wish. Now we can see when we go back to that query, we've got our customer ID and it's clearly ordered in ascending order. But how is it doing that? We're not telling it the way in which it orders. And that's because with order by there's a couple of options. So we can actually specify ASC, or we can write out, no we can't, we can actually specify ASC that represents ascending, or if we leave it blank, the default is actually ascending. So if we just specified that, we'd see we get exactly the same results, because leaving it blank represents exactly the same as we want it in ascending order. Okay, what about if we wanted it the reverse? So if we wanted to say, we do want to order by customer ID, but we want it in descending order, or total due. Total due is actually a better column for us to use. Maybe that's more realistic in terms of the real world. So we want to find out on top who spent the most money with us. So we then simply change this to descending, so DESC, which represents descending. So when we're using descending order, we do have to state the DESC. So if we execute this now, remember we're only ordering in this case by total due, and we can see that here. If we are to remove the desk or the DESC and change it back, we can see we've defaulted to ascending order. So when we want to return columns sorted in descending order, we do actually have to explicitly state that. What I tend to follow is, for ascending, I don't tend to put it. I would leave it out completely, because it's just not necessary. I know that if nothing's there, it's sorted in ascending order, whereas for descending you do have to specify. So it does help differentiate between the two quite well. Now let's say we wanted to mix and match our ordering. So let's say we wanted to order by customer in ascending order, but then we wanted to order by total due in descending. How would we go about that? So it's very simple to just modify this to say we want to order by customer ID and then total due descending. So you can see clearly here the differences between the two. I think that shows up quite nicely compared to if we actually specified it out. I think it's easier for me to see that customer ID will be ascending, total due will be descending. Execute the query, and we can see for customer ID 11,000 we have the highest amount of total due at the top. And as mentioned before, we might get the same amount of total due per customer, and we do, and we'll look at that a bit later on in the video. Now, we've covered there the basics of ordering, how we can guarantee our results are returned, what we need to do in terms of tiebreakers. We need to look for a unique column that we can order by. And let's say we want to do that tie breaking, but we don't really care about returning the column. So let's say sales order ID. It doesn't mean anything to the query. The only purpose of it being in the query is to break those ties. So let's take it out, and what we can do is, let's say if there's a tie with total due descending, we then want to order by sales order ID. Execute the query. So now this is quite different from what we've been going through. So all we're returning is the customer ID and the total due. We're returning by customer ID in ascending order, then by total due in descending for those customers, and then if the total due was the same amount, we're ordering by sales order ID, but we're not actually returning that. So that's one of the benefits by using order by, is that if you do need the results guaranteed to be in a certain order, you don't actually need to return that column. Now, just before we move on to limiting our result sets, What I wanted to discuss was in regards to order by, is it's fine when you're just writing general queries, but unless you actually need the results in a guaranteed order, you will receive much better performance if you leave the order by off. So what's actually got to happen is SQL Server's got to go to where this data is stored, pull the data back, and then make sure it returns it in this order, which could be more work. And if that work isn't necessary, if you don't actually care what order the results are in, then it's better to leave it off. So if we have, say, a front-end application, so imagine we had an AdventureWorks web portal where customers actually ordered their bikes. We could leave the ordering to the application layer, so when that application calls the database to return results, we could pass those results back non-ordered, and the application could actually deal with that ordering. So it's just something to bear in mind. It's fine to write queries and practice using order by, but unless the order of the results is important to you, then it's not necessary, and you can leave it off and you'll probably see your queries return results faster. This is quite a small table of only 31,000 rows, but if you're working with bigger databases where you have millions of rows in a table, you probably don't want to be ordering that result set. Speaking of tables with millions of rows, we're going to move on to our next part of this, which is how do we limit result sets. So let's execute this. So again, we've taken off our ordering and we know we've got 31,465 rows. What's also interesting to note here is I've taken off my ordering, and compared to the query that we started off with, we've now got different results. So I'm selecting customer ID and total due, and the results don't appear to be in any order, and that's because I'm not explicitly stating that I want them to be ordered. So the next key part of working with SQL Server, especially with tables with millions of rows, generally we want to work with a smaller result set than millions of rows. We want to work with the smallest result set possible. So how do we limit what's actually returned? And that's where top comes in. So let's say I just want to have a quick look at these columns, see what information's in there, and then I'm going to begin writing a query from there. So I don't actually want to return all the information. So I can write select top, and then I'm going to specify, I always prefer to put this in parentheses, but you don't have to. I'll show both ways shortly. So let's say I just want to return 10. So I'm going to say select top 10 customer ID total due from sales.sales order header, and notice again it's not ordered. So if we have a look at executing that query, we can see we've only actually got 10 results. And as I mentioned, I always prefer to put that in parentheses, but you don't actually have to. You can just write the number 10. So when we specify just the number, that is stating we want 10 rows. And we could also add an ordering. So let's say we want to see order by total due descending. Let's say that we want to see the top 10 values. So again, we've ordered the results, but we're still only selecting 10 of those results. Okay, now the other option we've got with top is we've just said top 10 here, and that's referring to rows. We can actually return a percentage of this table. So after we specify 10, let's write the word %. Now we know this table's got 31,865 rows, so 10% would be 3,168.5, so 3,169 if it rounds up. Execute the query. Maybe my calculation's wrong. We've got 3,147 rows returned. And we can enter any value in here, so we could say 1%. And then we get 315 rows. So that's another option. Now we're going to change this to order by total due ascending. And what I wanted to show you here is the total due, so we can see that we've actually got multiple values that are the same against different customers. So if we was to, let's remove percent for now, if we were to say top 2, and notice we're ordering by total due. Now we know this customer has got the lowest amount, that's on its own, but then we have then a massive selection of customers who all have the same value. We're only ordering by total due, so when we execute this query, which one does it choose to return? Well, it can actually choose any of those customers to return, because the result is still correct, because as mentioned previously, total due is not a deterministic value. So it knows we want the top 2, it knows we wanted it ordered by total due, but it knows that what we're saying here is it really doesn't matter to us which one you choose, just show us 2. How can we get around that? Well, the one option is what we showed earlier, was we could bring in a tiebreaker such as sales order ID, or another option with top is to include ties. So if we specify with ties, execute the query, we can see all of the customers that had the same value, and there is quite a lot of them, have actually been returned. So what this means is order by total due, give us the top 2 rows, but actually include the ties. So if there's any other rows that match the value in those top 2, include those as well. So it's quite confusing to say select top 2 and get 140 rows returned, but the with ties specifies that anything else that matches those values is also included. So we'll end this video with a little challenge, and try this out before you watch me go through the demonstration. So let's see if we can return just the customer ID. So we only want to return the customer ID, but we want to return the customer ID for the highest total due amount. So pause the video, give that a go yourself, let me know how you get on in the comments, and I'll now demonstrate how we could go about that. So I'm going to start completely from scratch. So we know, as specified, we only want to return the customer ID. And that's from our sales.sales order header table. Now we know we want to return the customer ID with the highest amount, so the highest total due. So what we need to then do is order by total due descending. Now this query isn't quite complete because we're going to return all customer IDs ordered by total due descending. So then we need to bring in top, and we're going to say top 1. We're not going to specify with ties, and it's going to limit our result set to the customer ID with the highest total due. If we execute the query, we have customer ID 29641. If we check our workings on that, we can then add our total due to our query, and we can see this customer's got 187,487 and a few pence. Now if we extend that to say top 10, just checking our working even further, we can see 187 is higher than 182, higher than 170. So we've got our correct answer there of 29641. Let me know in the comments, did you get that correct? No problem if you didn't, we're all learning. Really hope you have enjoyed that video. I do have other videos coming along over the next couple of weeks in the SQL Basics series. Feel free to check out the other videos on my channel. Subscribe to the channel if you haven't already and hit that notification button to be made aware of when new videos are uploaded. Thanks a lot for watching.